Hello everyone. Am I audible? Just mention in the chat if I'm audible. Am I audible, guys? If you have not subscribed to our channel, you need to be you have to just subscribe in order to reply, in order to comment. Yes, okay. All of you know that if you are watching our channel for the first time, in the video description, I have mentioned the WhatsApp group links for PGCET MTech. Please join them. And in case you're preparing for GATE examination, join the respective WhatsApp group as well. We have mentioned WhatsApp groups of both uh, PGCET MTech as well as the GATE examination, so you can join. Today is our first session, so I'm explaining the topics that are common to all the branches. And once we are done with the common topics, then we will be taking up the specific topics that are present for computer science examination only. And those, whatever examination you are writing, you have the syllabus. And just refer only to KEA website for the sake of for PGCET related information. And if you are somebody who's preparing for GATE examination, the concepts are same as PGCET for you. Most of the syllabus is same. It's just that the difficulty level of the questions will be more. So we will have separate sessions for GATE exam, wherein we'll address more complicated questions. So in case you are preparing for GATE exam, then you can join the respective WhatsApp group. If you're preparing for PGCET MTech, then both the WhatsApp group links are given, and Telegram channel link is also given. Please join that to access all the resources that we upload. All these notes that you can see right now on the screen, these notes, previous year question papers, practice questions, all that will be shared in both WhatsApp and Telegram. But in Telegram, if you join, you can access even the previously uploaded resources. And you know, the resources, the notes, the documents will be available forever in Telegram, whereas in WhatsApp, after couple of weeks, you won't be able to access and listen until you download and save it. Okay. So in today's session, we will be learning about matrices and determinants. It's going to be a 1 hour session and we won't be able to complete it fully. We will continue it in tomorrow's session as well. Okay. So first, what is a matrix? All of you know very well. So a matrix is a rectangular arrangement of numbers in the form of rows and columns. And order of a matrix is number of rows into number of columns. So that is order of a matrix. So here we have 2 rows and we have 3 columns. So order of this matrix is 2 cross 3. So this is order of a matrix. And for example, if you have to construct a 3 cross 4 matrix, this type of questions will not come for your exam. Okay. So if you have to construct a 3 cross 4 matrix where elements are given by Aij is equal to 2i plus 3j. So Aij. So here I denotes the row number and j denotes the column number. You can fill each and every element using this formula 2i plus 3j. It's just an example. You will not get this type of questions for your exam. We will solve previous year questions also. But we do not have too many previous year questions because from every topic you can expect only 1 or 2 questions for the exam. The number of topics are way too many. You will be able to get just 1 or 2 questions for the exam. So I will give you more practice questions. Practice as many as possible. Previous year questions, we have very few. All of you, are you all comfortable in English, or do you want me to explain with a little bit of Kannada as well? Please mention in the chat. English is fine, or do you want a mix of both Kannada and English? Complete Kannada, it is practically not possible. So if you want a mixture of Kannada and English, I can do. Please mention in the chat. English is fine, or both Kannada and English preferred. Please put it in the chat. Okay, so we know what is a matrix, and then we have order of the matrix. Next, types of matrices. Row matrix is one which has only one row. Row matrix is one where number of rows are only one, number of columns can be many. Then we have column matrix which has only one column. So number of columns will be only one, number of rows can be more than one. Zero or null matrix is the one in which all elements are zero. So row matrix is the one where we have only one row. Column matrix is the one where we have only one column. And zero matrix is where all elements are zero. That is called as a zero matrix. Singleton matrix is there where is only one element. So when you have one element, it means it has one row and one column. So that is a singleton matrix. You can see here within brackets, you have only one element, something like this. So it has one row and one column. Order of a singleton matrix is 1 cross 1. It has just one row and one column. Next is horizontal matrix. Horizontal matrix is where number of columns are more than number of rows. Number of columns are more than number of rows, so it looks like this. Then vertical matrix is the one in which number of rows are more than number of columns. See here, we have 2 rows and 4 columns. Number of columns are more, so it looks wider. And here we have 4 rows and 2 columns. Number of rows are more, so it looks longer. Therefore, this is called as vertical matrix. Square matrix, all of you are aware, number of rows is equal to number of columns. So it has a square shape. We have number of rows and columns are equal. Okay. Next we have diagonal matrix. Diagonal matrix is the one in which only diagonal elements are non-zero, all other elements are zero. Okay. Only diagonal elements are non-zero, all other elements are zero. So diagonal matrix is only with respect to a square matrix. Rectangular matrices cannot be diagonal matrix. Okay. So because we talked about diagonals only in square matrix. In a square matrix, these elements, it is called as the diagonal elements. Only diagonal elements will be non-zero. All other elements will be zero. So that is called as a diagonal matrix. In this diagonal matrix, if all the elements are equal, then it is called as scalar matrix. Okay. See, we have 2, 3, 4 here. Whereas in scalar matrix, all other elements will be zero and these elements will all be equal. You can see here -7, -7, -7. Can be negative number or positive number, but all the diagonal elements will be zero, or will be equal. That is called as a scalar matrix. Next, we have unit matrix. Unit matrix means all these diagonal elements are equal to 1. It's equal to number 1. That is called as unit matrix. It is also known as identity matrix and it can be written as I. So if you have, again, unit matrix is a square matrix. If you have an identity matrix or a unit matrix with 2 rows and 2 columns, we denote it as I2. If we have an identity matrix with 3 rows and 3 columns, we denote it as I3. See, this is I3, okay, where I3 means 3 rows, 3 columns, and only diagonal elements are 1. So I2 means 2 rows and 2 columns, only diagonal elements are 1, all other elements are 0. This is I2. I4 means 4 rows and 4 columns, only diagonal elements are 1. So we have 4 rows and 4 columns. 0, 0, 1, 0, then 0, 0, 0, 1. So this is 4 rows, 4 columns with only diagonal elements as 1. So this is called as I4. So I stands for identity matrix, which is nothing but a unit matrix where only diagonal elements are equal to number 1. All other elements are equal to 0. Okay, that is unit matrix. Next we have triangular matrix. So here in diagonal matrix, I told you that if you have this diagonal elements are non-zero, all other elements are zero. Here, this triangle, the elements that are above this diagonal, these are called as upper triangular elements. Observe carefully, these are called as upper triangular elements. And elements below the diagonal, these elements are called as lower triangular elements. Okay, lower triangular elements. So there is a diagonal. Above the diagonal, whatever elements are there, those are called as upper triangular elements. Elements below the diagonal are called as lower triangular elements. Okay. Now, if the upper triangular elements are zero, then the matrix is called as a lower triangular matrix. In which triangle, okay, in which triangle elements are present, that will be name of the matrix. Okay. Upper triangular matrix. A square matrix is said to be triangular matrix if elements above the principal diagonal or below the diagonal are zero. So upper triangular matrix means, see, lower triangular elements are zero. Okay. If lower triangular elements are zero, it is called as upper triangular matrix. If upper triangular elements are zero, then we call that as a lower triangular matrix. Okay. So this is a lower triangular matrix because upper triangle is zero. So the triangle in which elements are present, that will be the name of the matrix. This is another type of square matrix. Next is singular matrix. Singular matrix means if its determinant is equal to zero, then we call the matrix as singular matrix. We will see how to calculate determinants. I'm sure all of you know, but still we'll see how to calculate the determinants. Matrix A is said to be a singular matrix if determinant of A is zero. Otherwise, it is called as non-singular matrix. This is about different types of matrices. Next, we have, okay, these are some certain important concepts that you can remember. You can take a screenshot of this. A triangular matrix is called strictly triangular if Aij is zero. That is, even diagonal elements are zero. And then multiplication of two triangular matrices is also a triangular matrix. Every row matrix is also a horizontal matrix, but not the reverse. And similarly, every column matrix is also a vertical matrix. These are certain important points that you can remember. Next, coming to symmetric and skew-symmetric matrices. We'll also solve some problems based on this. First, we will understand some types. Symmetric and skew-symmetric matrices. Symmetric matrix means the rule is Aij is equal to Aji. Aij is equal to Aj means along the diagonal if you fold the matrix, okay? So you have principal diagonal, along the diagonal if you fold the matrix, the elements coincide. That is, see, this is a diagonal elements. This and this is same, this element and this element are same, this one and this one are same. So if you fold the matrix along the diagonal, the elements that coincide are equal. So Aij, that is first row, second column, and second row, first column elements will be equal. Aij is equal to Aji. This is the definition of a symmetric matrix. Next, coming to skew-symmetric matrix. In skew-symmetric matrix, Aij is equal to minus Aji. That is the same way as the symmetric matrix. When you fold the elements across the diagonal elements, the coinciding elements will be opposite in sign and the diagonal elements will be zero. Okay, and Aii, that is same row number and column number. See, this is first row, first column, second row, second column, third row, third column. Okay, diagonal elements will be zero. All other elements which will be having opposite sign of the coinciding element. See, this is 2, here we have minus 2. This is plus 1, here I have minus 1. Here I have minus 3, here I have plus 3. So with opposite sign, here we'll have that is called a skew-symmetric matrix. In symmetric matrix, the elements along the diagonal, if you fold it, should be same. And in skew-symmetric matrix, diagonal elements will be 0 and other coinciding elements will have opposite sign. That is skew-symmetric. Is it clear so far? Any question? Some more results are given. You can go through that. I will share this PDF with you. You can go through all this. Okay. Next we have Hermitian matrix, not necessary for you. Trace of a matrix. So if A is a square matrix and B is another square matrix of the same order and lambda, it is a constant, then trace of lambda into A is equal to lambda into trace of an element. These are common results with respect to trace. Now, what is this trace of a matrix? Is that if you have, okay, square matrix is given, fine, here they have not, like transpose. First, we will discuss about transpose. Transpose of a matrix. Transpose of a matrix is obtained by interchanging rows and columns of a matrix. That is called transpose of a matrix. And properties of transpose is given. We will have to use it in solving many questions. When we use the when we use the properties, we will discuss about this in solving problems. And then we have, okay, so that is about different types of matrices. Then we have equality of matrices. Two matrices are said to be equal if their corresponding elements are same. Addition of matrices, A plus B is same as B plus A. It is commutative law. And this is associative law. That is, if you have to add three matrices, first add A and B, then add C. And that gives you same answer as first adding B and C and then adding A. And zero is O is a zero matrix. By adding it to A, you will get A only. So zero matrix is called as additive identity of a matrix. And negative of a matrix is called as additive inverse of a matrix. Okay. And subtraction of two matrices in. Now, the actual thing, the difficulty or the confusing part comes here. That is multiplication of matrices. There are two types of multiplication. One is scalar multiplication and then multiplication. And then you have matrix multiplication. Scalar multiplication means we multiply one single number to all the elements of a matrix. That is called as scalar multiplication. Look at this. So if you have a matrix A and if you write 2A, it means multiply 2 to all elements of A. Suppose I'll take A like this. Suppose A is 2, 3, 4, 5. Okay. 2A is multiply this 2 to all the elements of this matrix. So 2 into 2 is 4, 2 into 3 is 6, 2 into 4 is 8, and 2 into 5 is 10. Okay. Multiply all elements of the matrix with this number. That is called as scalar matrix. Matrix multiplication. That is called scalar multiplication. Matrix multiplication means you take the first row of, you take row of a first matrix, we multiply with first column. Then you take this first row, multiply with second column. Then take this first row elements, multiply with third column. So take first row of the first matrix, multiply with all the columns of the second matrix. Then take second row of the first matrix, multiply with all columns of the second matrix. So this is your matrix multiplication. And for this to happen, number of columns in first matrix should be equal to number of rows in second matrix. Only then matrix multiplication is possible. Number of columns in first matrix should be equal to number of rows in second matrix. If A is a matrix of order m cross n, then B must have, here if you have n columns, then for multiplication to happen, B should have n rows into any number of columns. Now, matrix AB, its order will be m cross B. Okay, so when you multiply two matrices, number of columns in the first matrix should be equal to number of rows in the second matrix, and product matrix will have this many rows and this many columns. That is matrix multiplication. And you know the condition when matrix multiplication is positive. Some properties of matrix multiplication is there. You can go through this. Then matrix division is not possible directly. For that, we use matrix inverse, which I think we will do it in tomorrow's class. Right now, we will solve some problems. Okay, we'll take some problems and we will solve them, and then we will take problems from previous year's question papers as well. Let me know if you have any questions. You can ask. Let us solve this question. Is everyone fine with the speed? Do you think it's fast or slow? Let me know in chat. Are you all fine with the speed? ನಿಮ್ಗೆ ಫಾಸ್ಟ್ ಅನ್ಸುತ್ತೆ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಸ್ಲೋ ಆಗಿ ಮಾಡ್ತೀನಿ. We will not be able to cover everything, but whatever we do, we will try to cover it slowly. And if you're okay with the speed, then we'll be able to cover a little more topics. I don't think I can cover everything because we've started very late and exam date announce agilla. Exam date announce admale. I don't know how much time we will have for preparation. But as much as possible, for how many ever days we have, we will try to cover it. Okay, speed is fine. Okay, only one student is responding. Yes, others, many are attending. And if you have already started preparing, say for example, matrices is something you have already prepared. You need maybe if you think theory of computation is something I want first, you can feel free to put it in the comment section. ನಿಮ್ಗೆ ಯಾವ ಟಾಪಿಕ್ ಫಸ್ಟ್ ಫೋಕಸ್ ಮಾಡಬೇಕು ಅಂತ ಅನ್ನಿಸ್ತಿದೆ. Say for example, I'm sure you would have already started preparing long back. So if you have already started preparing, if you have completed certain topics, I'm going in some specific order. If you have already prepared some topics, and if there is any topic you think it's difficult and you want that to be taught first, you can put it in the comment section. You are in the WhatsApp, if you join the WhatsApp group, and you can also mention in the WhatsApp group if you are looking for any specific topics, so that we will cover that first and then we will try to cover the other topics. ಎಲ್ಲಾನು ಮಾಡೋಣ, ಬಟ್ ನಿಮ್ಗೆ ಯಾವ್ದು ಪ್ರಿಫರೆನ್ಸ್ ಇದೆ ಫಸ್ಟ್ ನಾವು ಅದನ್ನ ಮಾಡ್ಬಿಟ್ಟು ಆಮೇಲೆ we will proceed with other topics. Okay, right. So we will solve this question. Find value of x and y if 2 into this matrix plus this is equal to this. So what all concepts we are using here? 2 into this. This is scalar multiplication. Okay, this is scalar multiplication. And then this two together, we are using addition of matrix. After doing that, we are equating to this matrix. This is called equality of matrices. So far we have discussed, right? These three topics we are doing using here. Now first, we will do scalar multiplication. Multiply 2 with all these numbers. Okay. 2 into 1 is 2, 2 into 3, 2 into 0, and then 2 into x. This is your first matrix. Plus, here we have y, 0, 1, 2. Okay, now I'll add this. Here I'll get 2 plus y as the first element. 6 plus 0 is 6. Then 0 plus 1 is 1. 2x plus 2. Understood? I'm adding corresponding elements. Okay. This 2 and y I have added. This 6 and 0 we have to add. Then 0 and 1 we should add. 2x and 2 we should add. Okay, after doing all this, we are supposed to equate it to this given matrix, which is 5, 6, 1 and 8. Okay, now 2 plus y is 5. 2 plus y is 5. So what is y? It is 3. And then 2x plus 2 is 8. 2x plus 2 is 8. So 2x is 8 minus 2, 6. So x is also 3. Rakshita says limits and continuity topic. Sure, Rakshita, we will do that. I've started with matrices. Today we'll do as much as possible. Tomorrow we'll continue this. We'll finish off determinants also. Then on Wednesday, today is Monday. Yeah. So Wednesday we will start with limits, continuity, differentiation. Okay. Fine. So now this is actual solution. Hinge ಮಾಡ್ಬೋದು. How to do it faster? I hope all of you have understood this. I would need more interaction in the comment section so that it feels very, lively, interactive. Now, this is actual solution. In this, if you have to get the solution fast, then do only that as much as required. Complete again ಇದು solve ಮಾಡೋ necessity ಇಲ್ಲ. Because you're not writing any descriptive question, you're not getting marks for steps, right? You have to just choose the correct answer. So make sure you're doing as less calculations as possible. What is that you need to find x and y? Here we have addition, right? So x ಎಲ್ಲಿದೆ ಇಲ್ಲಿದೆ. So ಆ term ಮಾತ್ರ ತಗೊಳ್ಳಿ. 2 into x is 2x plus ಅದನ್ನ ಇದ್ರ ಜೊತೆ add ಮಾಡಬೇಕು. 2, which is equal to this number 8. So you get only that one particular equation you can get. Understood? Similarly, where is y? Y is here, which is first row, first column. Add it with this after multiplying. 2 into 1 is 2 plus this is y, which is equal to first element 5. So basically we have done this only. Instead of doing this lengthy step, I'm directly writing this step. Okay, 2 plus y equals to 5, 2x plus 2 equals to 8. If you can do this, do it. See, always remember, don't be in a hurry and don't do mistakes and lose marks. It's important to save time. It's also important to avoid mistakes. Once you practice all this, then you will be able to directly solve. You can skip the steps and directly arrive at this solution, arrive at this stage. Suppose it is confusing for you. Suppose you might make mistakes, then it is okay to write one additional step. Make sure that you are solving it without mistakes. So this is where it's not a shortcut. It's just that you are solving only how much is required. ಕಂಪ್ಲೀಟ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡೋ ನೆಸೆಸಿಟಿ ಇಲ್ಲ. ಎಕ್ಸ್ ಅಂಡ್ ವೈ ಫೈಂಡ್ ಮಾಡಬೇಕು. ಎಕ್ಸ್ ಇಸ್ ಸೆಕೆಂಡ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಎಲಿಮೆಂಟ್, ವೈ ಇಸ್ ಫಸ್ಟ್ ರೋ ಫಸ್ಟ್ ಕಾಲಮ್ ಎಲಿಮೆಂಟ್. ಅದು ಮಾತ್ರ ಆಡ್ ಮಾಡ್ತೀವಿ. ಇದೆಲ್ಲ ಬೇಕಾಗಿಲ್ಲ. ಓಕೆ, ದಿಸ್ ಅಂಡ್ ದಿಸ್ ನಾಟ್ ನೆಸೆಸರಿ ಓನ್ಲಿ. ಸೊ ವಿ ಡೋಂಟ್ ನೀಡ್ ಇಟ್ ಓನ್ಲಿ. ಸೊ ವಿ ಕ್ಯಾನ್ ಕೀಪ್ ಓನ್ಲಿ ವಾಟ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್. ದಟ್ ಇಸ್ a way to quickly solve the question without wasting much time. Fine. So we will take the next question. So as I told you, how much ever is required, only that much we will solve once I told you, right? So we will do that here. But this problem we have to solve completely. Find value of A, B, C, D if this matrix is equal to this matrix. Now here you see there are 4 parameters required, right? 4 variables are there. So how do you solve it? In these two equations, in both of these two equations, we have A and B, and here AC and CD are there. So use these two equations first, solve it as simultaneous equations. That is one way of doing. But if you have options, you can use options. Here we don't have options given. Options ಕೊಟ್ಟಿದ್ರೆ ನೀವು direct options substitute ಮಾಡಿ simplify ಮಾಡಿ. Options ಕೊಟ್ಟಿರ್ತಾರೆ. Okay, so ಇಲ್ಲಿ we'll see how to solve. But actually, if you're getting this in exam, then solve it based on options given. Okay, Prevention has a question. When we refer previous year question or gate question, difficulty level is more. Like we use logarithms and limits in matrices. How to solve such questions without wasting lot of time? Then you should have good practice. Okay, so you definitely need good practice, and for many questions there are shortcuts, and for many questions there are standard questions and you have standard solutions for that. We will discuss all of them as much as possible. But see, when I'm taking class, we'll have to start from basics. So I'm starting from the basics. Right now, the problems that we are doing are very simple problems. Going forward, we will take little advanced problems also. And especially if you're talking about the GATE exam, the questions will be very difficult and time consuming. So we will have separate sessions only for GATE. Concepts will remain same, but problems of GATE examination are not required for PGCET. For PGCET, you don't have that much of difficulty questions. More difficult and complicated, lengthy questions we will solve separately for GATE section. but the concepts all remain same. So you have to start with basics only. And more and more when you practice, you'll be able to identify which question needs how much time, and you'll be able to solve it quickly. So that is one thing. And all the questions will not be time consuming. Okay, there will be certain, we will going forward, we will also do time management sessions where I'll tell you what type of questions you should attend first, what type of questions you should keep it to the end. All the questions in your exam will not be lengthy. Very few will be lengthy. So try to save time as much as possible in easier questions. So lengthy questions, you have to take time. There are certain questions where you definitely need 3 minutes to solve. There you cannot reduce time. There won't be any shortcuts. You have to solve it and you will take 3 minutes time. So if you're taking 3 minutes time for a question, means in many other questions, you should have saved a lot of time. Okay. Practice will give you that required speed. And as I told you, many times you will be able to solve it from the options. So right now in these example problems, answers are not there. So I'm solving them. Wherever we have multiple choice answers, we will see how to get the answer from, how to pick the answer from the options. In that way also you can save time. Okay, right. Now we have four options here, four variables for which we need to find the value. We will take first these two equations and we'll simplify this to find out value of A and B. Okay. A minus B is -1. 2A minus B is 0. A minus B is -1. 2A minus B is 0. Now I will subtract the second equation. I'll change the signs. A minus 2A is -A. Minus B plus B gets cancelled. And here we get -1. So A is 1. We got the value of A. Now take any of the variable, any of these equations and find out the value of B. Let me take this first equation itself. A minus B is -1, right? Minus B, I will take it to right hand side, it becomes plus B. This -1, I will take to left hand side, it becomes +1. A is 1, 1 plus 1 is 2. So value of B is 2. Now we will find out value of C. I'll take this equation, 2A plus C, that is equal to 5. 2A plus C is 5. A is 1, so 2 into 1 is 2, plus C is 5. 2 plus what gives you 5? Is 2. And now take option, the third equation, which is 3C plus B equals to 13. C is 3, so 3 into 3 gives you 9. 9 plus B is 13. Therefore, D is 4. Now, when you are solving this type of question in the exam, again, you don't have to solve it completely. Take any two options, any two equations, solve it. You got option A as 1. Variable A as 1. Look at the four options given. If there is only one option in which value of A is 1, then mark that as the answer. You don't have to find out the values of other variables. Suppose there are more than one option in which A's value is given as 1. Then find out B. After you find out B, look at the options. If only one of the option has this 1 and 2 as A and B, then you don't have to find out the answer for remaining questions. Always try to find uh, I'll always try to do as much less calculations as possible to arrive at the solution. Once you know, okay, this is the solution because there is no other possibility, you don't have to proceed further. Don't be in the, what do you say, in the urge of completing the entire solution. It is not necessary. Okay. Right. Now we will take the next question. So here, this is similar to simultaneous equations, but they have given matrices. Find x and y if 2x plus 3y is a matrix and 3x plus 2y is another matrix. They solve it like simultaneous equations. For left-hand side, we simplify it like simultaneous equations. Same multiplications we do for right-hand side also. Okay. So 2x plus 3y is there. And then we have 3x plus 2y. How to solve this? To solve it as simultaneous equations, we will have to make one of the variables coefficient same, right? So first equation I'll multiply with 3, second equation I'll multiply with 2. Okay. First equation I'll multiply with 3 and second equation I'll multiply with 2 so that in both the equations we will have 6x and when we subtract one equation from the other it will get cancelled. We will get the value of y. So let us do that. For first equation, I'll multiply with 3. This entire equation, I'll multiply with 3. And this entire equation, I'll multiply with 2. Okay. So first equation multiplied with 3. Left hand side and right hand side completely will multiply with 3. 3 into 2x plus 3y. 3 into 2x is 6x plus 3 into 3y is 9y. That is equal to, we will multiply this 3 into all these numbers. 3 into 2 is 6, 3 3s are 9, 3 4s are 12, and this is 0. This is your first equation. Okay. Now, second equation is this. This I'll multiply with 2. The entire equation, both left hand side and right hand side, I'll multiply with 2. 2 into 3x is 6x plus 2 into 2y is 4y equals to, inside matrix, I'll multiply 2 for all the elements. 2 into 2 is 4. 2 into minus 2 is minus 4. This is minus 2. 2 5s are 10. Now we will subtract second equation from the first equation. We should change signs. So this is minus, this is minus, this is minus. So this minus sign should be applied for all the elements inside the matrix. So this 4 and 10 are positive. It becomes minus 4, minus 10. This minus 4, minus 2, they're already negative. So applying minus sign to this, it will make it positive. Now let us subtract and see what we get. 6x minus 6x gets cancelled. 9y minus 4y is 5y equals to 6 minus 4 is 2. 9 minus of minus 4 is plus 4. So 9 plus 4 is 13. 12 minus of minus 2 becomes plus 2. So 12 plus 2 is 14. 0 minus 10 is minus 10. This is 5y. From this, I can write what is y. Y is equal to 5 goes to the other side. It becomes 1 by 5. Y is equal to 1 by 5 into all this. So let us multiply this 1 by 5 inside all these elements and find out what is the answer. Or you can just keep it as 1 by 5 into all these elements you can write. Now, how should I divide each of these elements by 5? Or can I keep it like this? You don't have to worry because you will anyways choose from the options. So nothing to worry. So this is Y. Okay, Y matrix is this. Now we should find out what is X. To do this, we will substitute in any one of the equation. I will take the first one. 2x plus 3y is equal to this. So here, 2x plus 3 into, in place of y, I will write this, which is 1 by 5 into 2, 14, 13, minus 10. Okay. And that is equal to 2, 3, 4, and 0. Multiply this, take it to the right hand side and subtract. 2x plus 3 into 1 by 5 is 3 by 5. 3 by 5 into 2 is 6 by 5. 3 by 5 into 13 is 3 into 13 is 39 by 5. Next, 3 by 5 into 14 is 30 plus 12 is 42. 42 by 5. Only minus sign is there only for one of them, is it? 6 minus 4 is 2. 9 plus 4 is 30. 12 plus 2 is 10. 0. Yes. 3 by 5 into minus 10. So it is negative. 5 2s are 10. 2 into 3 is 6. This is your 3y matrix. Okay. This is 2, 3, 4, 6. Now, this matrix will come to the right hand side. It becomes negative. So 2x is equal to, right hand side we have this matrix which is 2, 3, 4, 0 minus, we should write this matrix which is 6 by 5, 39 by 5, 42 by 5, then minus 6. Okay. So we get, okay, we'll subtract and write 2 minus 6 by 5. 2 minus 6 by 5, 5 into 2 is 10. 10 minus 6 is 4. So we get 4 by 5 here. Next we have 3 minus 39 by 5. 3 minus 39 by 5. So 5 into 3 is 15. 13 minus 39, you will get 26 minus 26 by 5. Then you have 4 minus 42 by 5. So 5 into 4 becomes 20. So 20 minus 42 is minus 22 by 5. And then you have 0 minus of minus 6 is plus 6. This is 2x. We are supposed to find out x. So what is x? X is equal to 1 by, this 2 goes to the right hand side, 1 by 2 into this entire thing, which is nothing but every element you should divide by 2. So I'll directly divide by 2 and write 4 by 5. When I divide by 2, I'll get 2 by 5. See, it is 4 by 5. I should divide by 2. Gets cancelled and we get 2 by 5. So basically, from numerator, you can cancel 2. Denominator, keep it as it is. Now, minus 26 when divided by 2, we get minus 13 by 5. Then minus 22 when divided by 2, we get minus 11 by 5. Then 6 by 2 is 3. This is x and this is y. Okay. So these are your options. Again, I'm telling you, you will have options to check. And once you get y, you don't have to find out x because from the options you can pick whichever has this as the y matrix. So you don't have to completely solve it when you have options. Since right now we do not have options, we are doing the complete solution. All of you understood the procedure of this problem? Let me know if you have understood the procedure. Yes. Any questions so far? In case you have any doubts with any of the steps, you can ask in the WhatsApp group also. Please do not send me individual messages because I'll be getting a lot of messages from individual, from students. So I would want to put it in the group itself so that if anybody else has solved, they'll also guide you. Uh, if there are any mistakes that you have done in your solution, other students will also be. It's like a group study, group is done for that reason. Okay, fine. And I will also reply. None of them have replied, I will also. Next question. Look at this. This question looks very lengthy, right? But actually this question is, you can solve it very quickly. Here you have 6 variables here, A, B, C, X, Y, Z. There are 6 variables and you are supposed to find values of all the variables. Very easy because you have individual variables that you can directly equate it. See, X plus 3 is 0. So what is X? X is minus 3. Now, look at the options. Which one has X as minus 3? Next, Z plus 4 is 6. Z plus 4 is 6. So, Z is 2. Okay. Next, we have 2y minus 7 is equal to 3y minus 2. 2y minus 7 is equal to 3y minus 2. 3y is there. 2y I will bring it to right hand side. It becomes minus 2y. Here I have minus 7. This minus 2, I'll bring it to left hand side. It becomes plus minus 2. I will take it to left hand side. It becomes plus 2. 3y minus 2y is y. 2 minus 7 is minus 1. Okay. X is minus 3. Z is 2. Y is minus 5. By this time, you will know what is the answer. From the options, you will know what is the answer. Then we have uh, this one. 2c plus z is 0. 2c plus z is 0. We have value of z. Z is 2. So 2c equals to z goes to our right hand side. It becomes minus z. Z is 2. So here you get minus 2. So c is minus 1. We've got values of 1, 2, 3, 4 variables. We have two more variables to find, which is a and b. X, y, z we got. T is there. A and b we should find. A minus 1 is minus 3. A minus 1 is minus 3. Minus 1 goes to right hand side. It becomes plus 1. A is equal to minus 3 plus 1 is minus 2. So we got value of A also. Next, we need to get value of B. So for this, we take this equation. B minus 3 is equal to 2B plus 4. Here we have 2B. This B comes to right hand side. It becomes minus B. This is minus 3. 4 goes to left hand side. It becomes minus 4. So minus 7. B is minus 7. That's it. But again, as I told you, you don't have to solve all this. By the time you get values for 2 or 3 variables, maximum 3 variables, you would have figured out which is the option. Always keep looking at the option. Whenever you have this type of questions where there are so many answers, after you solve few steps, you have a look at the options. You will know what is going to be the answer. You don't have to completely solve it. Okay. So all of you understood so far whatever concepts we have discussed. Now we will start with some of the we'll learn about determinants and we will see how to apply properties for determinants. The second will I'll take determinants. Okay, all of you know how to calculate determinants, right? How to solve determinants. So what are determinants? Most important properties I will explain. You can note that. So determinant is a numerical value attached to a matrix. It's a single numerical value attached to a matrix. So what is this determinant? We explain determinant first with the help of a 2 cross 2 matrix and then with a 3 cross 3 matrix. Determinant is only applied for square matrices. For rectangular matrices, determinant does not exist. Okay. So if I take a 2 cross 2 matrix, okay, if A is a 2 cross 2 matrix, which is A, B, C, D, then determinant A means we write like this, or DET we write, where we write vertical lines. If we have square matrix, square brackets, it is some matrix. If we have vertical lines like this, it's a determinant. We multiply principal diagonal elements minus we multiply the secondary diagonal elements. So A into D minus B into C. There's a minus sign, remember, A into D minus the secondary diagonal elements. This is the determinant of a 2 cross 2 matrix. If you have a 3 cross 3 matrix, which is A, B, C, D, E, F, G, H, I. So this was a 2 cross 2 matrix, and now I have taken a 3 cross 3 matrix. Here, how do we calculate the determinant? Now, first take the first element. So we will take this first row elements and multiply with 2 cross 2 determinants obtained by excluding its row and column. So let me take the first element A. Okay. Now leave its row and column. This is the column and this is the row where that A belongs to, right? A is in the first row, first column. Leave first row and first column. Now we are left with these 4 elements. Find out determinant of these 4 elements. E, F, H. Now for second element, you should take a minus sign. Minus B. Now leave this row and this column. B is present in first row and second column. Leave that row and this column. You get these 4 elements. D, G, Fi plus C into, leave this C is present in first row, third column. So leave this first row and third column. You get these four elements. Find out determinant of these four elements, which is D, G, E, H. Okay. So this is how you find determinant of a 3 cross 3 matrix. Now, this 2 cross 2 determinant can be simplified using this way and then multiply this way. So you will get A into EI minus FH minus B into DI minus FG plus C into DH minus, this is E, no? EG. So 3 cross 3 determinant can be expanded similar to a 2 cross 2 determinant. We'll take the first row elements, leave its row and column, and we evaluate the determinant obtained by eliminating the row and column. So this is how we calculate determinant for a 3 cross 3 matrix. Now, in the problems that they give, we usually do not use this expansion because they'll have too much of simplification required if you do this way. There are certain properties that you have to use. Use the properties and reduce the matrix to whatever possible, how much ever simple you can do. Simplify to that extent, and then you will be able to use this technique to simplify them. So first, when a determinant is given, you have to reduce it. You have to simplify it. After simplifying, you apply this to get the final answer. And when you're simplifying itself, certain properties, if you notice, you can immediately know what will be the answer. So what are the properties that we usually apply? First thing, in a diagonal matrix, okay, properties of determinants. If you have a matrix and it's transpose is interchanging rows and columns. Determinant of a matrix and its transpose are same. Okay. If A transpose and A, for both of them, if you calculate determinant, you will get the same value. If any two rows or two columns of a determinant are interchanged, then sign of the determinant changes, which we usually do not do because that will not simplify your problem. It will just add another additional step. So in simplification, we will not do. Just learn it as a property. If any two rows or two columns are identical or proportional, then value of the determinant is 0. What does it mean? Suppose you have a matrix A, determinant A, which is like this: 2, 3, minus 1, 4, 8, 7, 2, 3, minus 1. Here, first row, this is row 1, this is row 2, and this is row 3. Here, row 1 is identical to row 3, right? Row 1 and row 3 are same. Therefore, this determinant is 0. You don't have to simplify. Determinant is 0 if two rows are identical, or if two columns are identical, then also the determinant is 0. Suppose I have 2, 5, minus 2 here, and here I have 2, 5, minus 2. You see, first column and third column are identical, means the determinant is 0. So if two rows are same, or if two columns are same, determinant is 0. Suppose two rows are not same, but you will get one row by multiplying a number to another row. Say, for example, if you have like this, 4, 10, minus 4. You see here, none of the two columns or rows are same. It is different. But look at the first column. We have 2, 5, and minus 2. If I multiply 2 to this, 2 into 2 is 4, 2 into 5 is 10, 2 into minus 2 is minus 4, right? If a row or a column is a multiple of another row or column, then also the determinant is 0. Understood this? So for first column, if I multiply 2, I will get third column. Okay, for first column, if I multiply 2, I will get third column. So from one column, if you take out any common factor, or if you say for C3, if I divide by 2, I will get first column, right? From column 3, if I divide 2 for all the elements, I will get first column. Same with rows also. If one row is there such that if I multiply a number to it, I will get another row. Or from a row, if I take out any common factor, I'll get same as another row. Then the determinant is 0. All of you understood this property? Then um, next we have, here it is not given. If you have a diagonal matrix, you know what is a diagonal matrix, right? Only diagonal elements are non-zero, all other elements are 0. So if you have a diagonal matrix, then its determinant is same as product of the diagonal elements. Okay, if you have a diagonal matrix like this, 2, 0, 0, 0 minus 1, 0, 0, 0, 3, something like this. This is a diagonal matrix because except principal diagonal, all other elements are 0. Here, the value of the determinant is just product of this. 2 into minus 1 into 3. Just multiply these three elements, that gives you the determinant. This is if you have a diagonal matrix. Next most important thing is that if you have a row or a column, to that you can add or subtract any other row or column or its multiple. That is, I can change second row by second row minus, or you can write second row plus. Understand how to write this formula. I'm sure all of you have done this elementary row operations and column operations. When you're doing this, if you have a row, you want to change the second row. To this second row, this right side of the formula, always start with R2 only. Like R2 is equal to R1 plus R2, you should not write. It's wrong. You can write R2 plus R1. It gives the same answer, but always have this practice of writing. If you're changing row 2, then keep row 2 in the beginning of the formula in the right hand side. Should not multiply any number, should not divide any number to this. Row 2 should be written as it is. After that, you can have plus or minus any other row, row 1 or row 3, anything. Or you can multiply another row and subtract. Or you can have something like this. All this is acceptable. Okay, if you're changing row 2, understand how to write this clearly. If you are changing row 2, then right hand side formula should start with R2. No multiplying or dividing any number. It should start with R2. After that, you can either add or subtract any other row as it is, or you can multiple of a row, or you can divide that row by something and then add to this or subtract this. Why am I doing this? It's because if you have to apply any of these properties, okay, this determinants, we have discussed certain properties now. If you have to apply those properties, sometimes you'll have to do some changes. You have to do some modifications to the matrix and then bring it to this form. After you bring it to this form, then we will be able to simplify it easily. So we will have to do such modifications to get the answer in a required format. Tomorrow we will solve determinant based problems where we are going to discuss all these properties in application. We will use these properties in solving problems. I want you all to go through this determinant properties once again. I'll share that PDF with you. Go through the example problems given in that so that tomorrow we can solve more problems. You will be able to understand these. So tomorrow we will solve determinant problems and we will take previous year question paper problems from MTech exam of different branches under these two topics, matrices and determinants. And going forward, like one of you asked, who asked, Rakshita, asked for limits continuity, we'll solve those problems after determinants, which is going to be in Wednesday's class. Okay, then, see you all in tomorrow's session. So I'm telling you again, if you're watching the channel for the first time, subscribe and click on the notification so that you will get a notification when when we post any video. And then join the WhatsApp group based on whether you're taking MTech exam or GATE exam. According to that, you join the WhatsApp group and join the Telegram channel for accessing all the notes and all that. Okay. So tomorrow we'll meet in the same time at 7 o'clock. There might be slight changes, like half an hour changes. Anyway, link I'll be posting in the WhatsApp group, so you can join accordingly. If you have any questions, if you need any notes, if you need any practice questions, and you practice from some other source, but you're getting any error or you're confused, you can put your questions in the WhatsApp group. I will solve as early as possible. Okay. Okay, then see you all in tomorrow's session. Bye bye.